Relative motion in one dimension. Before understanding relative motion, first let us clear the concept of frame of reference. Whenever there is motion on the surface of the earth, be it from a monument, using your feet, a vehicle, or a spaceship, everything will be taken with respect to surface of the earth. So earth basically is our frame of reference. Whenever there is motion, we consider it with respect to the surface of the earth. But what about relative motion in space? When you have nothing to keep as a reference, then what will happen? For this video, definitely the four corners of the screen of the device that you are using are going to be your references, but try to imagine the motion of these two spaceships in space without any reference around them except for each other. Let us imagine you and your friend are stranded in the universe. Your alien ships have run out of fuel. So the only motion that is happening is because of the drift of your ships. So if your friend moves towards you or you move towards your friend, who's to say who moved? Because from his ship it may appear that you are moving towards him while actually he was moving towards you. So that is where relative motion comes into picture. There is relative motion between the objects and the moving object itself becomes the frame of reference. If you have ever traveled by train, then you definitely have experienced the effects of relative motion. Consider this train over here. It first appears that the observer is moving towards a stationary train. During the course of the motion of the trains, it appears that both the trains are moving in opposite direction with slow, steady speed. Skipping towards the end of the motion, we realize that our train was always stationary. Relative velocity in one dimension is rather easier to understand. When two objects are moving in the same direction with the same velocity, then their positions do not change with respect to one another. So, with respect to one another, their relative velocity is given by the difference in their velocity, in this case VA minus VB, that will be equal to 0. Since there is no relative motion between them, hence relative velocity will be 0. For two objects moving in opposite direction, the relative velocity will be given by VA minus VB, because the direction of one object is opposite to the another one. Hence, the resultant will be the sum of their velocities, hence VA plus VB. Note that VAB means that velocity of A as seen from B. Keeping the simple concept in mind, let us solve an example. A train of length 200 meter traveling at 30 meter per second crosses another train of length 300 meters traveling at 20 meter per second in the opposite direction. Find the time taken by the first train to pass the second. Now, as you read the question, the scenario should come into your mind. The first train is of 200 meter length. It is traveling in one direction at 30 meter per second. The second train is coming from the opposite direction. It has a total length of 300 meters and is traveling at 20 meter per second. Our aim here is to find the total time taken by the first train to completely cross the second one. So, the motion we consider will start at this point. The trains will cross each other such that even the last portion of the first train has completely crossed the second train. Hence, the total distance covered over here will be equals to 200 plus 300, that is the total length of both the trains, that will be 500 meter. Relative velocity, since they are traveling in opposite direction, it will be added, hence VA plus VB, that will be 20 plus 30, 50 meter per second. So to find the time, we have total distance upon velocity, that will be 500 upon 50. So the answer is 10 seconds. You can also assume that train A is moving at 50 meter per second, that is the relative velocity, while train B is stationary. Such assumption will help you get a clear scenario when the objects are moving in same direction and certain lengths of one object has to be covered with respect to the second object. That is all you need to know for relative motion in one dimension. Pick up your reference books and practice many questions to understand the concept completely.